Welcome back to our channel. My name is Teacher Smith and today we are going to understand a very important principle on divisible. Now to understand this, I have taken an example from past year SASMO question number 22. So without wasting any more time, let's get started. So here the question says, Tom creates 4-digit multiples of 4 using each of the digits 1, 3, 6 and 8 exactly once. How many such 4-digit numbers can Tom create? Let's understand the question first. Here the question says there's a boy whose name is Tom. Now Tom creates a 4-digit number. Let's say this is a 4-digit number. And to create this 4-digit number, he can only use digits like 1, 3, 6 and 8. Now this 4-digit numbers he can create, but have to make sure it is a multiple of 4 that is present. So we can try out any combination of the number. But to check if this number is multiple of 4, do I have to divide each number by 4 to check if it's multiple of 4 or not? Will take a lot of time, right? Because there will be a lot of combination. So instead of that, let's just figure out how we can check if a number is divisible by 4 or not. For this, we have to see what is the divisibility test of 4. So let's understand this using a short example. So let's say there is a number. There is a 5-digit number that is 1, 2, 3, 4, 5. And I have to check if this number is divisible by 4 or not. Now one method is directly dividing it by 4. But that's the normal method, right? Instead of this, let's try to find out how we can quickly check. Now, to understand this, what we need to do is, I'll split the number into its place value. Like how? Let's say this 1 that is present. Now, 1 is a digit. But does that mean the place value of 1 is just 1? Of course not. 1 is at 10,000's place. So here I can write down 1 as 1 times 10,000. There will be 4 0. Now, regarding the 2 that is present. Is it just 2? What is the place value? Of course, it's 2, which is at thousands place. So I can write down plus 2 times 1000. Now regarding the 3 that is present, of course, we know it's at 100 position. So it's 3 times 100. And then we have 4, which is at 10's place. So I'll write down plus 4 times 10. And lastly, we have this 5. So I'll write down plus 5. It can be the 5 times 1 or 5. Now we have to check if the number after splitting is divisible by 4 or not, each of the term. Now to check this here, let's say 1 times 10,000 that is present. Is this divisible by 4? Yes, 10,000 is divisible by 4. So we know even if it's 1 times 10,000 or any digit times 10,000, it will be divisible. Now regarding this 2 times 1,000, we know 1,000 is divisible by 4. So even 2 or any digit will be divisible. So this is also fine. Now the same thing 3 times 100. 100 is divisible by 4, which is 4 times 25. Similarly, instead of 3, if I put any other digit, this digit will also be divisible by 4. So here it's correct. Now let's check this digit that is present here. 4 times 10. Now 4 times 10 is nothing but 40, which is divisible by 4. But apart from 4, if there is any other digit, like say 5, is 50 divisible by 4? Let's say 6, 60 divisible by 4. Yes, it is. 7, 70 divisible by 4. So we are not sure. Some numbers are divisible, some are not. So regarding this digit, there will still be a question based on the digit that is present here. So we are not sure. Same thing goes to the last digit that is here, it's 5. It can be any other digit. So we are not sure regarding the last and the second last digit if it's going to be a multiple of 4 or not. So what we can understand from here, if I split the number into its place value, all the digits are divisible by 4. Just the last 2 digits we are not sure if it's divisible or not. So regarding the divisibility test of 4, what we have to do is, we have to just check the last 2 digits. If the last 2 digits is divisible by 4, the number is divisible by 4. If it's not, then not. So currently for this example, I just have to check if 45 is divisible by 4 or not. So here I'll write down 45 divided by 4. And when we divide this, what will I get? It will be 11 and there will be a remainder of 1. This means it is not divisible by 4. So here, in order to check any number if it's divisible by 4, just check the last 2 digits. Now, it's not just 4 that is present. There is another number that shares the same divisibility test with 4. And that number is 25. Let's try to understand how that is present. Let's say, if I write down a number that is 2 times 5. Now, 2 times 5 is nothing but how much? 10. This means if I want to check if a number is divisible by 5 or not. This means I just have to check the last digit. Now last digit here is 10, that is 0 that is present. Now it doesn't matter if it's 10, 100 or any multiples of 10 that is present. It is still going to be divisible by 5 because we just have to check the last digit. Now the same thing if it's 4 times 25. Now 4 times 25 is nothing but 100 that is present. And I just said, if for 4, if we just check the last 2 digits that is present. So here the last 2 digits are 2 zeros that are present here. So the same thing we can do to check for 25 also. Because if it satisfies for the last 2 digits here, no matter what the multiple of 10 is, it will satisfy. So here for 25, we just have to check the last 2 digits. Then if I increase the number, that is 8 times 125. Then it's nothing but 1000 that is present. So how many digits do I have to check for 125? Yes, we just have to check the last 3 digits that is present. So what we can understand from this example? We understand the divisibility test of 2 numbers. It's 4 and 25. So let's summarize this. Here, to summarize this, if I want to check if a number is divisible by 4 or 25, how many digits do I have to check? Yes, just the last 2 digits. So I'll write down, check if the last 2 digits are divisible by the number. Now, understanding this, let's go back to our question. Now, our question says, he wants to create 4-digit number. So let's say these are the 4 digits. But this 4 digit has to be created from the digits that is nothing but 1, 3, 6 and 8. But as I just said, the question says it has to be a multiple of 4. Now for multiple of 4, what was the condition? Yes, we just have to check the last 2 digits. The last 2 digits should be divisible by 4. So let's see which digits we can use. Currently we have 1, 3, 6 and 8 that is present. Now, for any number to be divisible by 4, the number has to be even number or odd number. Of course, it's going to be an even number, right? So, the last digit should be even or odd? Yes, it should be an even digit. So, here, out of these digits that are present, how many do I have even digits? Yes, it's either 6 or 8. So, here, the last digit I can put only is 6 that is present. 6 or 8. Now, let's start with 6. Now, if I put 6 as the last digit, what can be the second last digit in such a way that it forms divisible by 4? Let's just check the very first number, 1 and 6. Is 16 divisible by 4? Yes, it is, right? So here I can put 16, that is 1 and 6 as the last 2 digits. So if the last 2 digits are 1 and 6, which 2 digits I can put here? Yes, the remaining that is present. I can either put 3, 8, or we can switch the places of 8 and 3. That is 8, 3 and last 2 digit remains the same, that is 1, 6. So keeping 6 as the constant, I got this 2 numbers that are present. Is this the only 2 numbers? If I keep 6 as it is there any other combination? 1, 6 I tried. Let's check 3 and 6. Is 36 divisible by 4? Yes, it is. So here I can either put 3 and 6 together. So if 3 and 6 is here, which digits I can put here? Yes, we can put either of the digits 1 and 8 or else can switch the places. So I can put 1, 8, the remaining 2 digits, or else I can put 8 and 1 and the last 2 digits can remain the same, that is 36. So what we can understand? Here just by pairing we can get the number. Now if 6 I keep as it is at the end, and if I put 8 now, 86, is this a multiple of 4? No. So here 86 is not possible. So regarding the pairing of 6, it's over now. Now apart from 6, which there is another even number. Yes, there is 8 that is present. So I can put 8 here. Now let's check. Is 1 8 possible? 1 8. 18 is divisible. No. Is 38 possible? 3 and 8. No. Is 68 possible? Let's just check. 68. 68 is divisible by 4. So here this number is going to be divisible by 4. So if I put 68, which digits I can put? Yes, I can put 1 and 3. Is this the only digit? Of course not. We can switch places, remember? So here I can put 6 and 8 and can switch places, that is 3 and 1. So is there any other possibility for even digit at the end? Of course not. So here we have covered all the possibilities. Now the question was asking how many. This means the number it's asking. So if we count the number that is present, it's like 1, 2, 3, 4, 5 and 6. So the final answer that we are looking for is 6 numbers. So what do we understand from this question? Here I have separated the numbers into the following digits and then we counted each possibility. This means we listed down each possibility. Now imagine if there's a lot of digits and if we keep listing all the digits, will take a lot of time, right? So instead of this, let's see how we can solve this question using counting principle. Now even if we use counting principle, our divisibility test remains the same. That is for 4. So here, if it remains the same by using method 2, let's see how we can solve using counting principle. Now regarding the last digits that are present, the last 2 digits, how many different ways are there in which we can put the last 2 digits? The last 2 digits has to be 16. Is there any other possibility? Yes, it can be 36 or else it can be 68 that is present. So regarding the last 2 digits, how many combinations do I have? Yes, I have only 3 of the combinations. That is 16, 36 and 68. Now regarding the first 2 digits that are present. So if the last 2 digits only has 3 combinations that are present. So the first digit here. If 2 of the digits are here, how many digits are left to place at the very first place? How many digits will be left? 2 digits are here. So there are 2 still digits that can be placed here. So the number of possibilities is just 2. Now just think. 1 digit is here, 1 digit at last place and 1 digit at first place. So how many digits I can put at the hundredths place? Oh, there's just 1 digit left here. So here it's just 1. Now in order to find out the total number of ways, total numbers, which sign should I put in the middle? Yes, we have to only put multiplication sign. And when we multiply, what do we get? We get 6 numbers. So no matter what, which method do you use, both the methods you can get the answer correct. But the most important part to remember from this question is about the divisibility feature of 4 and 25. So regarding the feature, what we can understand, to find out if a number is divisible by 4 or 25, just check if the last 2 digits are divisible by the number. So by understanding this, if you have any of the doubts, you can reach out to me. And by the way, this week, we are conducting a free open class on 9th of March from 3 to 4. And I'll be the one conducting this session. So if you are interested to join this open class on age problems, you can scan the QR code to register. Or else you can contact me directly. I'll help you register for this open class. For now, I'm Teacher Smith signing off right now, but I'll see you in the next video.